In this transmission system example, the concept of Remedial Action Schemes, or RAS, is introduced. Study case 02A. CA with RAS, single time phase, should be activated. Remedial action schemes are objects which are stored in the operational library. A simple RAS will consist of a trigger and an action. If the RAS is considered during contingency analysis, and the conditions defined in the trigger are met for any contingency, then the action will automatically be carried out for that contingency. Let us look at an example. Here, a RAS has been set up to reduce the output of two generators if a particular line is overloaded as the result of a fault. The trigger is that the loading on NEL3 is greater than 100% post-fault. The actions are to reduce the output of both NEG1 and NEG2 by 200 MW. The RAS is not related to any particular contingency. The generation reduction will happen for any contingency which causes this overload. There are 7 contingencies selected in the contingency command. We run these and can see from the graphic coloring that at least one causes an overload on NEL3. We can also see this by running a report. Now we will execute the contingency analysis again, but this time consider remedial action schemes. For now we will only consider the one RAS. There is also an option to be notified in the output window every time a RAS is considered. We can see that the RAS has successfully reduced the post-fault loading on the circuit. Searching for trigger in the output window shows us that the RAS was triggered once, by the contingency NEL4. Let us now add more RAS into the list for consideration. The contingencies are run again. We can see that it is possible for one contingency to trigger more than one RAS. If it is necessary for a remedial action to be specifically for one fault case, the trigger should be set up to reflect it. Here, the trigger is the opening of specific circuit breakers as a result of the fault. The actions model a generator intertrip. The generator breaker for NEG1 opens, and in this example 2 other generators increase their output in order to replace some of the lost generation. In this scenario, we have one circuit already switched out. Let us further assume that the adjacent circuit is downrated. If this double circuit is faulted, line NWNEL4 is likely to be overloaded. Let us first look at the situation without RAS being considered. By executing the contingency as a single contingency, we can observe what happens on the graphic. Now we can repeat with the RAS being considered. The generator trips and the load on the circuit is brought under control. It is possible to construct more complex trigger definitions. In this case, for example, we have 2 trigger conditions, combined with an AND logic. The first is that there has been a fault on busbar BB in substation NW01. The second is that there is some generation running. For the purposes of illustration, this trigger has been constructed using a logical gate, where the state of each of 3 generators is considered. The internal triggers in the gate each check if one of the generators is off. Use of the negation flag and the OR combination means that the trigger is only activated if one or more of the generators is generating. The action triggered is a drop in the local demand. Logical gates can be nested, and further flexibility is provided by allowing the user freedom to select any variable for consideration. A check button is provided on the RAS to help the user ensure that the RAS triggers and remedial actions are valid. And there is a description field, which is particularly useful for documenting more complex remedial action schemes.